So now I'm gonna explain how can we do the same thing, the flashing LED, but using C language. Okay, so here in C language we have some operators here. So this operator is actually a logic. Let me make it make the color. So in C language, we have some operators you need to learn. So the first operator is this one, the ampersand here, this operator, okay? So in this operator, this actually is gonna do bitwise or bit by bit logic AND, and this operator for OR, okay? This operator for XOR, this operator for NOT. I'm gonna give you examples now. This operator for shift, right shift, and this one for left shift, okay? Remember, let me say something here. So give me 1 second. Remember, what is the difference between this operator here and this operator? And this operator here and this operator, what is the difference? Very big difference. This operator here, guys, is they are used if you want to make a condition, compound to condition. For example, I can say if A greater than 2, okay, and okay, B less than 5. That means I'm gonna execute the body of if this condition is true and this condition is true. The two conditions should be true. Is that okay? Same thing for this one, but this is OR. So what I want to say is these two operators here, guys, are used if you want to make like condition like this one. Okay, so this operator. Now, what about this operator? Completely different. Completely different. This operator, like what you are gonna see right now, they are gonna be used for logic operations. Logic operations. Okay. So it's gonna be bit by bit AND, bit by bit OR, bit by bit this one for XOR. Okay. Exclusive OR. So I'm gonna give you more details now, but I just wanna make you should understand what is the difference between these two operators. Okay. So I'm going to give you some examples here. For example, guys, in C language, I can say something like that. Port P, and in C language, you can use the word port P, okay? It's like a variable or something like that. I can say port P should equal port B and this number, okay? What this means? It means this is port B. We're going to do FE, F, as you know, it's 1, 1, 1, 1, right? E, E is, I think it's 0, 1, 1, 1. Anyway, whatever it is, okay? So we are going to do actually bit by bit AND this one, and the result is going to be stored in port B. Is that okay? So what this one is doing, you are going to do bit by bit AND operation, okay? And then you store the result in port B, okay? Someone can ask me what, let me get the eraser here. Eraser here. So someone can ask me now, okay, what is 0x means? What this 0x means? Okay, I'm going to tell you. My answer is that very simple. Do you remember in assembly when I told you percent and dollar sign, just to tell if this if this number is binary or hexadecimal or whatever? Okay, same thing. But here we are going to use the different symbols in C language. So here in C language we are going to use 0x if you mean this is hexadecimal. So this means hexadecimal. For binary, I think I wrote it somewhere here. Let me check. Yeah, here. Look here, guys. So if I say I equal 42, that's what you used to do in C language. Okay, that means I should equal the number 42, which is decimal number. If I put here 0x as a prefix, okay, that means this is hexadecimal number. If you put 0b here, guys, so 0b here in C language is similar to dollar sign. 0x, I'm sorry, it's similar to percent, right? And this one is similar to dollar sign as we did before. Okay, so So this is the way we can do end operation. Okay, someone can ask me, you remember I taught it before. I told you if you want to clear, if you let me put it here, just give me 1 second. Yeah, let me put here. Okay, so here in chapter 2 I explain if you want to clear some bits, what should you do if you want to clear some bit? I told you you can use bit clear, which is a very easy way, or the other option you can use AND. Do you remember what I said here? Yes, you can use AND to clear some bits. Okay, so the idea is that, for example, the bits you want to clear, you have to put 0. If the bits you don't want to change, you have to put 1 here, and then you can do AND operation. So as a result, these bits here no change. You're gonna get them without any change, and this bit should be 0. Okay, that's what I explained before. Okay, so in assembly we had the option we can use bit clear or we can use AND, and I think it's easier just to use bit clear. That's what I said. But in C language we don't have an instruction like bit clear, so we have to use AND. Okay, same thing. How can you set some bits? As I said, in assembly we have bit set. Also you can use OR. Okay, so the idea is that if this is a byte and now I'm going to use OR and I want to set a certain bit, I have to put 1, and then the bits I don't want to change, I have to put zeros. Is that okay? So these bits that have zeros here, I don't want to change, so I'm going to get the bits without any change. And this one, because it's 1, whatever there, I'm going to get 1 here. So by this way I can set some bits. Okay, that's what we're going to do again in C. For if you remember, how can you flip some bits? That's what I did before. So the idea, in order to flip some bits, you have to use XOR. And in both in C and assembly, you don't have an structure like bit set and bit clear. Okay, so the way you have to do it, as I explained to you before, if you have a byte and I want to flip the first bit, I have to put 0, and then I have to put I have to put 1, and then the bits I don't want to change, I have to put 0. By this way, if this one is B0, what I'm gonna get here B0 prime, and these bits no change, no change. Is that okay, guys? That's what we're going to do actually exactly in right now in that's what we're going to do right now here. Okay, so here if you wanna, by this way, whatever the number you can put here and you can use AND operation, but this way you can clear some bits in port B. Is that okay? If you want to set some bits in port B, you can use this operator here, and you have to use the correct number as I have just explained. Okay, one more thing, guys, as you know from C language, this command, it can be written like this one, exactly same thing. Again, if you are, for sure this one is maybe easier to read. If this one is easier, you can use it all the time. But if you see something like that, that's what you did in C language, but maybe you did it using other operators. For example, I can say I equal I plus 2. It's the same thing if I say I plus equal to, right? This is exactly the same thing. Again, if you like this format more, just use it, no problem at all. Okay. Same thing here, guys. I want to explain how can you flip or how can you toggle some bits. Okay, so the way I did it, you can do this way, but again you have to use the correct, you have to use the correct number here. Is that okay? Again, you can do this way. Okay, look at this instruction here, guys. This operator here, guys, is going to do complement. I already explained in chapter 2 what's complement. Okay, just you flip all the bits. So look at this interesting instruction. What this instruction is going to do, you are going to take port H. As I'm going to explain later, port H is connected to switches. Okay, so I'm going to read port H, and then I'm going to flip all the bits, and then I'm going to send it to port B. Port B is the LEDs. You got what I'm saying? So the LEDs. So that means, you know what this instruction is going to do? If the switch is connected, the LED is on. If the switch is connected, the LEDs is off, because this instruction is going to read the switches. Okay, and I'm going to give you details later, but just for now I'm explaining. Okay, so in C language, guys, don't be confused. We're going to use the names of the ports. The ports we have. Okay, the name of the port B, port H, and so on. We can use them like variable, like I and J. Okay, so that's you don't need to define them because already they will be defined in the file. Okay. One more thing here, guys, you can see shift instruction. I can say port B equal port B shifted 3 times. So here you shift 3 times port B, and now you store the result in port B. You can store it somewhere else, but what I want to do here, I want to shift to port B. Okay. Same thing here, but this is shift here, shift right, here shift left. Okay. Okay. So just read this example just to understand. Maybe when you learn C language, maybe you didn't take this operators here. That's what I have just explained right now, guys. Logic operators or relational and logic operators. This operator are used if you want to make a condition. Okay, like for example, if I equal to 2, if I does not equal 5, right? If I is greater than 2, if I is greater than or equal 5, whatever, J less than 2, right? And so on. And this one's, that's what exactly explained now. This is if you want to make like 2 conditions and you want to connect them using AND. Okay. Here, I'm going to leave this is a very easy slide. I'm going to leave it. This is just like a quick revision on if statement. Okay, so maybe I'm going to go quickly through it. You remember in if statement, if you have only one, if the body of if has only one instruction, so we don't need to use braces like here. Okay, if it is more than one instruction, you have to use it. Okay, here I put if not equal, if it is greater, and so on. So this is just a very easy. Here, this is a complex condition. That's what I told you about here. So here we are going to execute. I'm going to execute the body. The body if this condition is true and this condition is true, both of them should be true. Okay. There is a very tricky point here. For sure, it's very tricky from C language. I want you to learn it. Okay. If you look here, guys, look at this one here. Look at this if and look at this if. Okay. So this is the only difference here. The only difference is using this ones here. Okay. Here it's not used, but these 2 instructions are going to do. Listen to me. This is a very important thing. These 2 instructions are going to do completely different thing. Okay. So how they are completely different? That's what I'm going to tell you right now. Okay. In C language, you know, when we execute like operations in C language, there is some priority rules, right? You remember? So here, for example, multiplication has to be done first, and then addition, and so some priority. So if you look here, guys, in C language, equal here, sorry, this equal here has more priority than this end. Okay. So what this instruction is going to do, this instruction is going to do this operation first. This is number 1. So what this one is going to do is, let me, okay, so it's going to do this part first. After it does this part, so the result should be one of 2 values. If they are equal, so the result should be one of 2 values, 0 or 1. Okay, 0 if the condition is true, if they are equal, 1 if 1 if they are equal, 0 if they are not equal. Okay, and then what we're gonna do now this instruction becomes PTH, which is port H, and number 1 or number 0. Is that okay? Now if the result is 0, so the result here can be 0 or not 0. Okay, if the result here is 0, that means the condition is false. If it is 1, for sure that's not what I want to do. What I want to do is, and that's anyway, later I'm going to explain it later in details, but I just want to explain this part now. So what I want to do is I want to calculate this one first, because actually, you know what I'm doing here? I want to check if a bit is connected or not. And let me quickly explain it here, because I already taught it before. You remember when I told you guys, if you want to check, I want to check if this bit is 1 or 0. Do you remember how I explained it in chapter 2? I told you we're going to use AND operation. I said we're going to put here 1, and then I'm going to put 0 everywhere. That's what I explained. Is that okay, guys? So, and because here when I put 0 here, I'm going to force. So here I'm going to get all zeros for sure, right? Because this is AND operation. Here, this one is 1, and this one is bit 0, so I'm going to get bit 0. Okay, so this is the result is here. And now, if you look at this bit, this byte should be one of two values. This as a byte should be value 0 equal 0, or this byte should equal 1. Okay, so if it is 0, that means bit 0 equals 0. If it is 1, it means bit 0 equal 1. Okay, that's how I can check if some bits are ones or zeros. Okay, that's exactly what I want to do here. What I want to do here, let me use the eraser. Oops. What I want to do here, guys, is, as I told you, for sure I'm going to give you more details later, but for now, here, PTH is the switches. The switches. Okay, let me show you what is switches here. Yeah, here. This is switches. Can you see these switches? I'm going to explain it later. So these switches are connected to port H. Is that okay? So if the switch is connected, so every switch, this is port H, right? If there is one bit for each switch. If this bit is 0, that means the switch is connected. If it is 1, it means it disconnected. Okay. So if I want to know if the switch is connected or not, all what I have to do, I have to check the bits, and that's exactly what I want to do here. So I want to check here. Here I want to check here. What I did, this is, look here. This is port H, PTH, and this is number 2. Number 2 means I'm going to put 0, 1, 0, 0, 0 everywhere. So that means I want to check this bit. I want to check this switch, the second switch here. Okay. Okay, so that's what I want to do. Okay. So the result here, if this result equal 2, so if this result equal 2, that means this switch is 1. So here the result of this one should be one of two values. It can be 0, or it can be number 2. Number 2 for sure if this bit is 1, because it's going to become 0, 1, 0, 0, 0, 0. Okay, so it should be 0 or 2. So if it is 2, that means the switch is disconnected. Okay, so what I want to do, what I want to say here, guys, I have to execute this one first, and after, because this one I'm going to check if the switch is connected or not, and then I'm going to compare it to 2 to know if this. Okay, but if you do this way, that's exactly what I want to explain here, guys. If you do it this way, it's gonna do something completely different. Okay, so this is the conclusion. The conclusion is that if you want to do this condition first, you have to put it in this way. Okay, so that I can execute this one first, and then I can check if this one equal. If you don't do this way and do this way, and you think it's exactly the same thing, no, they are not the same thing, because in C language this equal has more priority, so it's gonna do this operation first. Okay, anyway. Now I'm going to explain. Now I'm going to talk about C language. Okay, how can we do the same thing we did before in C language? Actually, the structure is going to be the same. So the structure of program is going to be something similar to this one. The only difference is that I'm going to use the format of C language. Okay, so let me tell you in C language what should we do in C language. What C language. That's what you have to do here, guys. You can see here, number 1, you have to do configuration. This is exactly similar to what we did before. Okay, so here in this configuration, port P, direction register of port B, FF. So here you configure port B as output. Okay, port J, you configure port J as output. Okay, port P, because this one is going to be used to disable 7 segment. Okay, is going to be output. Okay, here port J, because you want to enable. So this here, guys, exactly same thing as we did before, but here I'm using the format of C language. Okay, exactly same thing. Also in C language you have to start with this function. It's called PLL initialization. This one is going to do some initialization to the system. Exactly, so this one is going to configure the system to clock to become 24 megahertz. So in C language, we are going to use this one all the time. Okay, and now you can see this is this part is just a configuration. It should be executed only one time. Okay, and now this is the program is here. Our program is here. You can see here in the program, guys, number 1, I have infinite loop, because while 1. This one means I have condition that's true all the time. So here you are creating infinite loop. Okay. In this loop here, guys, we have a function. Okay. This function is called LED on. Okay. This function. Okay. You have to. This function is gonna turn one LED on. Okay. And you have to tell me which LED. That's why I have to put number here from 0 to 7. Okay, because we have 8 LEDs. So here, this function is going to turn the first LED on. And then we have another function, millisecond delay. So this one is going to make a delay for 1000 millisecond, which is 1 second. And then we have another function, it's called LED off. Is that okay? So this one is going to turn the LED off here. Okay, and then we are going to wait 1 second, and then I'm going to keep repeating. So here you turn the LED on, you wait 1 second, you turn off, you wait 1 second. As you see here, I'm using a lot of functions. Okay, so these are the summary of the function I'm using here. Summary of the function we have. If you go to the course website, you will find on the course website I have a summary. Let me show you. I have a summary of the function. We have many functions in C language. Okay, just give me 1 second. Okay, so here, let me the slides here. Okay, chapter 3. In chapter 3, guys, you will see on the course website, I have, where is, yeah, C functions here. Okay. Okay, guys. So here on the course website, you have a file like this one. This file actually has a summary of all functions we have in C language. So you can, yeah. So these are all the function in C language I'm gonna teach. Okay, guys. One more thing, guys. All these functions are written in assembly. Okay, and we call it from the C language. Let me say this again. Okay. All these functions are written in assembly, and you call this function from C. Okay, that means, can I modify this function, or can I modify this function, or I can add a new function? I write it in assembly. For sure you can. And because of that, I'm here. I post a course. I post a tutorial online. In this tutorial, I'm teaching you how. I'm teaching you how can you add a new function in C. Right? How can you add a function? This function is written in. This function is written in assembly, and you call it from C. Okay. Before, this file is already online, but before I explain this function, I want to tell you something very important, guys. Okay. What we did see so far is you used to open Code Warrior, right? And then after you open Code Warrior, you select file, new project, and you create a new project, and then you write your own assembly program and then run it. That's what we used to do. Is that okay? For C language, the story is somehow different. For C language, the story is somehow different. Why it is different? Because if you make file, new project, and okay, this new project is not going to have this function. I told you I'm going to teach a number of functions. Okay, where are these functions? I think I closed it. Okay. Yeah, just give me a second. Okay, can you see this function, guys? This function are not coming with this function are not coming with Code Warrior. This function, we created these functions. Is that okay? These functions are written in assembly, and we call it them from C language. Okay. So if you make a new project to run a C program, okay, and you can, if you write this function, it's going to tell you, it's going to give you error. It's going to tell you this function are not defined. Okay, so what should you do? I post on the course website a project in C language. Okay, let me open. One second. Yeah. So on the course website, I post a project. That's what I'm telling you here, guys. Again, when you run any C program, the story is somehow different from what we did before in assembly. Okay, in the course website, I give you a project. This is the name of the project, as you see here. It's on the course website. Okay, you have to download this project and you have to open this project. Okay, so after you open this project, okay, you are going to have a program like that, like something like that, main.c. This is the program. Is that okay, guys? So if you want to run any C program, all what you have to do is you have to delete this program and then write your program here. So why I have to do that? Because in this project we define all the C functions. Is that okay? Let me summarize in what I said in one sentence, guys. Okay. If you want to run a C program, what you have to do is you have to use the project posted on the course website. As I'm explaining here, you have to download it, you have to unzip it, and then you have to run this way. After you run, you just delete this part and then put your program here. Is that okay? Otherwise, if you don't do that, why you make it this way? We are not used to do it this way in assembly. Yes, we made it this way because these functions, the functions we are going to use in C language, are defined here, and you can find them here. Okay, in this project. Okay, so now in this tutorial, I'm teaching. Okay, after you open this program, this project, I'm teaching here how can all the function. You can see all the function here, guys. I'm in details. Okay, if you want to add a new function, what should you do? Okay, I'm explaining here what you have to write this one here in this file. You have to define it here, and also I'm teaching here. You can see that this is assembly. Yes, this is assembly. Okay, you can find it here in this project. Okay, for sure. For the purpose of this course, guys, I'm not gonna ask you to write a program in assembly and call it in C. I'm not gonna do that. Okay, but just if you want to learn how to do it, on I already posted this tutorial online. You can look at, you can check, you can see this file. In this file, you can see how can you make a new function, how can you modify the existing functions. Okay, but for the purpose of this course, I'm gonna only teach the functions. Who can just use the function, but here I'm explaining how can you create a function in assembly. Okay, and how can you call it from C. So I created this function. Okay, like display LEDs 1 2 3 4. I created this function. I'm teaching you how to do it. Okay, I'm not gonna spend more time on this one because again, this is somehow I'm not out of the scope of the course. In C language, you have a number of functions. All what I want you just use these functions. Is that okay, guys? But again, I want to repeat another very important thing, guys. Let me summarize what I said here. The very important point, guys. Again, if you wanna run assembly program, like you have to do what you did before. You have to open Code Warrior, file, new project. That's what you have to do. And then you write similar to what you did before, no change. Okay. Now, for C, language, it is different. For C language, please don't make file a new project and then you select the C language. If you do that, okay, for sure it's going to work, but the functions I'm going to teach in chapter 3 is going to tell you this function that don't exist. You got what I'm saying? So the way you have to do it, you have a project online. Every time you wanna run a C program, you have to use this project. So you have to download this project, you have to unzip it, you have to open it. After you open it, just write your program here. Okay, why you have to use this project all the time? Because the functions we are going to use in this chapter are already defined here. Okay, so now let me return it to the C language here. Okay, guys. Now I want to teach I want to teach something else here, guys. Let me delete this one here. Just give me 1 second. Oops, there is no erasure. Okay, so here, that's what I explained here, guys. So you can just use functions this way, as I explained, okay. I want to teach something also else here. We have also some functions in C. This function is called LED enable, okay. We have another one is called LED enable. We have, oops, sorry, I wanna make it red. Just give me 1 second. Yeah. So here LED enable. We have another one, 7-segment disable. Okay, as I told you guys, if you want to use the LEDs, you have to disable the 7-segment because all of them are connected to port B. I have to only to use one of them. Okay, and that's exactly what I did here. If you look at this program, guys, that's what I did here in the configuration. But what I want to teach is you can do the configuration this way. Okay, or you can use functions. That's what I'm going to teach here. So here, that's what I did here, guys, in the configuration. For port B, I have to configure port B output. I have to configure port G input. Look at this one, and this one, and this one. Is that okay? This three, 1, 2, 3. 1, 2, 3. Okay. So here, the first two here, I have to configure port B and port G output, and here I have to put 0 in port G in order to enable LEDs. You know, guys, these three instructions are already in this function, LED enable. You see what I'm saying? So it's up to you. You have the option. If you want to do this way, like this way, you can use this three instruction to configure port B, port J as output, and then put 0 on port J. This is one option. The other option is you can just use this function. So you already here. Okay. Same thing for 7-segment disable. So 7-segment disable. Actually, we have this one. You have to configure port P as output, and then you have to put one in the first four bits on port P to disable. So these two instructions are already here in disable. Okay, it's up to you. You can use for configuration. You can use this one and use this one. But I want to tell you something you should understand. Okay, what should you understand here, guys? This format. So this one is okay. If you like this one, you can use it. I'm okay with it. It's totally fine. It's totally fine to use this one. It's totally fine to use function. Both of them are exactly the same thing. And if you go inside this function and see what is written there, you will find this instruction are written there. Okay, but you should understand something. You should understand this format. Yes, I'm writing it in C language, but this format is like assembly. It's exactly like assembly format. Okay, well, yes, it is C language, but the way we write it, the details written here, it's like what we did in assembly, right? This one is like more toward this what a high level. So this is let me make it use better terms to avoid confusing you. So the format here is like low level. The format here is like high level. Okay, so here it's like high level. You don't need to know what port is. You don't need the details, right? Again, if you either way is okay to me. Whatever you think it's okay, just use it. It's okay to me. But you should understand this one is like low level because it has some hardware. It's closer to assembly, but this one is like high level. Anyway, okay. Same thing here, guys. Look here, guys. LED on number 1. So this one is gonna turn. I told you what this function is doing. This function is gonna turn one LED on, and you have to tell me which one. So here I'm gonna say turn LED 1. Okay, you can put it this way. You can use it this way if you like, or you can use OR operation this way. Again, whatever works, whatever you like is okay to me. Okay, again, this is like a low level format. This is like high level. High level, as you know, as I told before, high level means I want you to be very far from the hardware, okay? Just to make it easy, programming easier, okay, guys? So if you want to use this one, is okay. Sometimes so I'm going to use this one. Sometimes I'm going to use this one. This one, both of them are exactly doing the same thing. Same thing here, guys. For port B, here, I want to turn the LED off. So here I'm going to use end operation, as I explained. Here you can use LED off, okay, guys? I'm gonna skip this program for now, and I'm gonna explain another. Okay, So now I'm gonna move to another program, okay? But before I move to another program, guys, I just want to summarize what is the important thing I explained, okay? Number one, guys, I told you we have a number of ports. That's what I said, okay? Number two, I said every port you should configure it input or output, okay? And this has to be done using data direction register. That's what I said. And this configuration should be done only one time at the beginning of your program, okay? Um, this is also what I explained, okay? Also what I explained, and this is very important, in assembly, we have a bunch of, we have a number of subroutines. All the subroutine, we put them in a file. This file is called subroutine, subroutine.include, and you have to include it in your program. And I forgot to tell you, when you include this file, okay, it's going to give you error. It's going to tell you counter is an error you will receive. Is tell you counter is not defined, because in the file, in the subroutine, I'm using a variable called counter. That means when you include the file, in your program you have to define counter dc.b, and you can put any number, 0, whatever, okay? Because I'm using a variable called counter, okay, in this subroutine, okay? Anyway, so that's what I said. For C language, I told you you have a project, you have to open this project, okay? And when you open this project, you can see all subroutines and functions. We have many functions I'm going to teach in C language, okay? And these functions are written in assembly, and you can actually we call this function in C language, okay? So now I'm going to teach serial. I'm gonna teach serial data, okay? This is just a simple program. I want to make like serial communication. You know what serial communication, like USB or something like that. The idea here, you have only one pin, okay? In this pin, we are going to send the data serial. So I'm going to send something like, as you see here, guys. So it's going to send 0, 1. So every certain time, okay, one bit. You can output one bit every. So this is data serial, 0, 1, 0, 1, 0, 0, 1, 1, 1, and so on, okay? So it's only one pin. On this pin, if you connect this pin to the scope, you will see something like that, okay? Sorry. Okay, so we want to do something like that. Okay, how can we do something like that? I want to this program. How can we do something like impose in? So if this is a signal, you can see the signal like this one here, guys. So here it's like a serial communication. It's like 1, 0, 1, 0, 0. 1, 1, 1, 1. Okay, and then I repeat it again. Okay, repeat it again. So it's like serial communication. Anyway, it's very easy. You can do it. I already explained every pin. How can you output 1 with 0 on each pin? Okay. So here, this is the idea. This is the pattern. This is the pattern I wanna display. So here, I wanna display it on PT5, I guess. Yeah. PT, yeah. So here PT0, yeah. If you look here, guys. So here I'm gonna configure port T. I'm gonna move to 1 here. So that means I'm PT0. So I wanna output this signal on PT0 here. Is that okay? So in order to do it, as you see here, guys, number 1, I have to configure port T. I have to configure port T as output. This is number 1. Number 2, here I'm using a variable called P, and this variable should have like this pattern. This is the pattern I want to generate. Okay, look at the idea, how it works. The idea is very simple. You have a byte here, guys. This byte should have like 1, 1, 1, 1, 0, 0, 1, 0. This is the pattern I want to generate. Okay, so what I'm gonna do, I'm gonna shift left, because I wanna output from here, starting from left to right. Okay, so here this one should get. So here, number 1, I'm gonna shift left. So this bit has to go to the carry, and then I'm gonna check the carry. If the carry is 0, so PT0 should equal 0. Else PT0 should equal 1. That's it. Okay, guys. So this is the main idea. The main idea. Number one, I'm gonna shift. When I shift, I'm gonna get one bit, and then I'm gonna check the bit. If this bit is zero, I'm gonna output zero. If it is one, I'm gonna output one. Very easy. Just look here. That's exactly what I did. What I'm doing here, shift left. When I shift left, so now I'm gonna check the carry. If the carry is set, if the carry is one, go to high. In high, I'm gonna set I'm gonna set port PT0. So I'm gonna output I'm gonna output one. Okay. If the carry is zero, so I'm gonna come here. If carry equal one, if the carry equal zero, I'm gonna come to here. If I come to here, so it means I'm gonna clear PT0. Clear it. Okay. This is the main idea. So the main idea, guys, is number one, I'm gonna shift. When I shift, I'm gonna get one bit in the carry. But when I shift, I have to shift left, not right. Why shift? Why left, not right? Because I want to output the bits this way. If you want to output the bits this way, the other way from right to left, so I have to shift right. But here, shift left because I wanna display, or I wanna output the bits from left to right. Okay. Anyway, so number one, shift. Number two, it checks the carry. If the carry is one, as I see here, guys, so means I'm gonna output one. If the carry is zero, I'm gonna output zero. Is that okay? Is that everything? No, it's not everything. Why? Because what I want to do now, I want to repeat the pattern. It's not only one time. I want to keep repeating it. Why? Why you want to repeat it? I want to repeat it because if you generate this pattern only one time, you are not going to be able to see it on the scope because it's going to be very fast. Is that okay? So as you see here, guys, in the scope, I have a certain pattern, and then I'm repeating this pattern. If you see here, the pattern from here to here is repeated. Okay, so I need to repeat it again. The problem is that, so what, okay, that's okay, we can repeat, but what's the problem? The problem is, after you shift, the variable P, we're gonna lose this pattern, right? So because every time you shift, you actually, let me erase it first. So here, guys, so what happens is that every time you shift, you actually put 0, 0, 0, 0, 0. So after you finish shifting, I lost the pattern, right? So I have to get the pattern again for next time when for the second round. Okay. So how can we do that? We have two solutions. After you finish, you can reinitialize the byte again with this value. Yeah, you can do that if you want. The other way is, well, that's what I'm doing here, guys. Look how it works. Okay, it works this way. I'm gonna shift left, and then I'm gonna go to the carry. Okay, this bit is gonna go to the carry, and now I'm gonna check the carry. If the carry equal one, I'm gonna or the carry equal zero. If the carry equal one, so what I'm gonna do, BT0 equal one, right? I have to output one, and I have to write one here, right? So that this bit is gonna be, it's like you rotate it again here, so that after each shift is, I'm gonna get the same pattern again. That's exactly what I'm doing in this program. So if you see what I did in this program, guys, let me explain it again. Number one, you shift. Number two, if the carry is high, I'm gonna come to here to do two things, not one thing, two things. Number one, I have to output one. So BT0 equal one. This is number one. Number two, I have bit set, so I have to put one here in P. So that like the bit I got here, I'm gonna put, it's like rotate. Actually, I think we got a lab on this, so it's exactly I'm doing here rotate. Okay. So that after each shift is, I'm gonna get the same number again and keep repeating. Okay. Don't forget, we need to add some delay here. So in every iteration, we need to add some delay because I cannot exit the bits very fast. So if you can see here, guys, every time I exit one bit, there should be some delay here. I have to wait some time. Okay. So I have to wait. Okay, that's exactly. So you need here. Let me erase this one. So what I did here, guys, number one, shift. Number two, if it is high, go to high. If it is low, go to low here. Is that okay? And then after I'm done, I'm gonna come to here. Here I can add a delay. You can add a delay, y millisecond. And then I'm gonna keep repeating again. Come here, keep repeating again. Yeah, you can do this well. Okay. I'm gonna explain now exactly same program, but in C language. Okay. Again, you have all these programs in the course website. Okay. This is the name of program. So the way I'm gonna do it here, guys, I'm gonna, number one, here you can see I have to, because I'm gonna use PT0 again. Don't forget, every time you use a port or a pin, you have to configure it first. So this is the configuration. One time should be enough. Okay. And now what I'm gonna do, something somehow a little different. It's the same idea, but somehow a little different from what I did before. What I'm gonna do now, guys, is I'm gonna check. Here I'm not gonna shift. I'm gonna use a different idea. Okay. So here I'm gonna check bit by bit. So I'm gonna check this bit. So I'm gonna put 1 0 0 0 0, and then I'm gonna do end operation to check this bit. Is that okay? And then two cases. This bit can be 1 or 0. Okay. If this bit is 1, so I have to output 1. If it is 0, I'm gonna output 0. Makes sense, right? And then this is in the first iteration. In second iteration, I have the 1 has to be here, right? Because I have to check next one here. Is that okay? So that's exactly how it works. Okay. So let me say it this way. So this is the number. This is the pattern. This is the pattern I want to generate. This is the binary pattern. Okay. So this is the pattern. Okay. What I'm gonna do is, in the first iteration, I'm gonna check something like that, because I want to check this bit. Okay. Next iteration number 2, I have to check this bit. In next iteration, the 1 has to be here. Is that right? And then next iteration, the 1 is here, the 1 is here, the 1 is here, the 1 is here. After I'm done, I have to come back to here to repeat again. That's exactly what I'm doing. Look how I'm doing here. Okay. So what are these values? This is a variable, we call it mask, as you see here, guys. So here I define, so don't be confused. I have here two variables. One is called pattern. This is the pattern I want to generate. This is pattern here. Okay. I'm going to use another variable called mask. This mask should help me so that I can check the bits. So the value of this mask should be in the first iteration, something like that, which is 80. That's why you can see this one is 80. Okay, 1 0 0 0 0 0 0 0. Okay, so this is next iteration. I'm going to shift it, so it's going to become something like that. Next one this way and so on. So if you look, this is a program here. We have infinite loop. Look what I'm going to do here. I'm going to do AND operations. That's exactly what I'm explaining here. I'm going to do AND operation between pattern, okay, and mask. So now I'm going to check one bit. In the first iteration, I'm going to check this bit. Next iteration here, and so on. Okay. And if the result is 0, what it means? If you do AND operation between 1 0 0 0 and the result is 0, that means this bit, the bit I'm checking right now, this bit is 0. So what I have to do, if the bit is 0, so I have to output 0. Right? Using AND operation. Okay, so I'm gonna output 0. Okay, else I have to output 1. So what I did here, guys, let me erase it. Look at this instruction here. What this instruction is gonna do, guys, I'm gonna check one bit. In the first iteration here, next iteration here, next iteration here, and so on. Okay, and then there are two cases. If this bit is 0, the bit I'm checking right now is 0, so I'm gonna output 0. Else I'm gonna output 1. That's okay. And then I have to delay. I have to wait some time, because as I told you, after I output 1, I have to wait some time. After I output 0, I have to wait some time, because this is how the communication is. I cannot just generate bits very quickly, because the other side, when the other side receives the receiver, there should be some time for the receiver to read this value. Anyway, so I have to wait some time, and then I have to shift mask. I told you mask should be in the first iteration 1 0 0 0 0 0 0 0. Sorry. Okay, and then it has to be 1 I think this one here, not here. And then next iteration, that's why I have to shift it. Okay, that's exactly what I'm doing here. So I shift it, right? I shift it so that next time I have to check another bit. 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 Okay. So until it is equal 0. When the mask equal 0, that means I shifted. I started with 1 here, and I shifted all the way. All the way. Okay. So here, if you see here, guys, what I did here. Oops. Let me erase it. Okay. So here, this part here, look at this part. So I'm gonna shift it. Why I shift? Because next time I want to check another bit. This number one. Number two, if mask equals 0, that means I shifted the 1 all the way. That means I have to return it to here again. Okay, so I checked all the bits. So now I have to return it back to here. Okay, so that I want to repeat. Okay. Uh, so yeah, here if mask equals 0, so now mask equal 80, which is 1000. Okay, so let me summarize what I did here, guys. Number one, I'm gonna check one bit, okay, and then if this bit is 0, I'm gonna output 0. If this bit is 1, I'm gonna output 1. Is that okay? And then I'm gonna wait, and then I'm gonna shift mask, mask. Okay, so this mask always, it's a byte, always has 1. Always it has only one bit. One bit is 1, and the other bits are zeros. Every time I shift it, I just change the location of this one. Okay, and now if the mask equals 0, so I have to bring it back again here, so that I repeat again. Okay, again, this is just a different idea from what I did here. What we did here, I shifted the pattern itself. Here I didn't shift the pattern. What I did here, I used a mask to check. So possible, this is programming. You can do things using different ideas. Okay.